Hello students, so welcome to this video, another video of mine. So today in this video we will be discussing about Kirchoff's law of electricity. Okay, so this law is there in your class 12 curriculum, class 12 physics current electricity chapter. So without wasting much time, let's go to the topic. Okay, so Kirchoff has given us two laws. Okay, so first law is Kirchoff first law, which is also known as junction law, right? Which is also known as junction law. And it states that the algebraic sum of electric current meeting at a junction. Now be very careful, this junction word is important, is zero. Okay, so what does it mean? The summation, I don't know whether it's summation or it's look like euro. Okay, so the actual symbol will be like this, so summation is zero. Now ये तो गया रटने का चीज, ठीक है, बट व्हाट इट एक्चुअली मीन, सी इट एक्चुअली मीन्स दैट सपोज this is a junction. Let me draw a circuit for you so that it gets very clear to you all. Let's say this is a circuit, ठीक है, we will be solving sums later in this video, ठीक है. So चलो, so I1 current, I current, and here it is I1, here it is I2, and let's say here it is I3. Now see, there are some conventions which we need to follow while we deal with the laws. Okay, so for the first law, remember convention says current entering a junction. See, this is the junction, na? This is the junction. Let us name it as A. Current entering the junction, entering a junction will have plus sign, ठीक है, plus sign, okay, and current leaving the same junction will have what? अगर एंटर करते हुए अगर प्लस हो जाए तो लीव करते हुए क्या होगा? माइनस ही होगा ना, इससे ज्यादा तो कुछ नहीं होगा. सो माइनस साइन. ओके, चलो. Now see, so if I am going to write it in a equation form, what I will write, see, this is entering, na, this I is entering, so plus I, and this I1 is leaving, so minus I1, I2 is also leaving to minus I2, I3 is also leaving to minus I3, and the summation is 0. ठीक है, and the sum, now you may ask कि सर वह कहाँ है, समेशन तो नहीं है, तो माइनस कर, देखो ऐसा लिख सकते हैं ना इसको, minus I1 plus minus I2 plus minus I3. Okay, and that's how it says ki summation of the algebraic sum or the summation of electric current meeting at a junction is 0. Clear na? So what from this, what we can write? We can write like this na, ki I equal to I1 plus I2 plus I3. Okay. Now, this is very important because without first law, you cannot solve the second law. Okay? And one more important thing, for the first law, this law is coming from where? See, every law is derived from another base law. Okay? So, keep this in mind. It came from law of conservation of energy. Law of conservation, sorry I said energy, it is not energy, energy is for the second law. Okay, this for the first law, it is law of conservation of charge. Okay, law of conservation of charge, keep this in mind. Okay, this is very very important. Okay, chalo, now let's move to the second law, which is the voltage law. चलो, so coming to Kirchoff's second law, ठीक है, so this law, this very law has also its name, it is also known as what? We can also call it as this voltage law. Okay, now the first law was junction law and this law is voltage law. Okay, now first law was algebraic sum of currents at a junction is 0. Second law is algebraic sum of EMF or the potential difference across a closed circuit. This is very important word. Closed circuit is 0. ठीक है, closed circuit होगा तो 0 होगा algebraic sum. So how we can write it as we can write it like this कि algebraic sum of V is equal to 0. ठीक है. Now V is what? V is the potential. ठीक है, potential difference or the potential drop. It can be the EMF of the cell also. ठीक है. अच्छा, now first law came from the law of conservation of charge. Okay, and this second law, this law came from where? It came from law of conservation of energy. Law of conservation of energy, which we all know that it's what it states. It states that energy can neither be created not destroyed. It can be transferred from one form to the other. ठीक है. Now ये तो सबको पता है, ये तो बुक में भी है, कर्शॉफ सेकेंड लॉ, कर्शॉफ वोल्टेज लॉ क्या है, कॉन्सिक्वेंस के. बट द मेन प्रॉब्लम जो आता है एग्जाम में कि हाउ टू सॉल्व कर्शॉफ लॉ प्रॉब्लम्स. ठीक है, how to use Kirchoff's second law to help ourselves so that we can solve any question whichever comes from this particular topic. Okay, so see, I am giving you 3 rule. Okay, just follow this rule and you will be able to solve any question from Kirchoff's second law. Okay, now first rule says that if we move in the direction of current. Okay, acha, before this first rule, the most important, select the loop. ठीक है. लूप माने एनी क्लोज सर्किट. ठीक है, व्हेन वी विल डिस्कस सम्स, ठीक है, वी विल आई विल टेल यू हाउ टू सिलेक्ट अ लूप एट योर ओन कन्वीनियंस. ठीक है, सो फर्स्ट रूल इज इफ वी मूव इन द डायरेक्शन ऑफ करंट. ठीक है, करंट जिधर जा रहा है, ठीक है, उधर अगर हम जाएंगे, देखो करंट कहां से कहां जाता है. करंट ऑलवेज फ्लोज फ्रॉम, ये सपोज करो एक सर्किट है, this is the short end of the battery, this is the long terminal battery. ठीक है, so current कहां से कहां flow होता है. current flows from the long end to the short end. long end is at higher potential and short end is at lower potential. So always keep this in mind. When if we move in the direction of current, माने we are moving from higher potential to lower potential. Okay, and in this scenario, what will be our voltage drop? Voltage will be negative. ठीक है, and voltage drop माने V equal to IR from Ohm's law. So it will be IR, but we will put the sign negative, which will indicate that we are moving to lower potential. ठीक है, R क्या है? R है resistance of the resistor. जो voltage drop कहाँ होता है? voltage drop होता है across the resistor. ठीक है, across the terminals. ठीक है, so whenever we will move from across a resistor whose resistance is R, if we are moving in the direction of current, then what will happen? Then we will put minus IR. Clear? That is the voltage drop across that resistor. Keep this in mind. Okay, now second rule is similarly moving against the direction of current. अगर हम लोग move current के opposite direction में जाए, so what will happen? So we are moving from lower to higher potential. And in this very scenario, what will happen? The voltage drop will be positive. Why positive? Because lower to higher में जा रहे हैं ना, तो automatically the voltage drop positive होगा. Because previously क्या था? higher to lower negative minus IR. So lower to higher it will be positive plus IR. Okay. Now if we move from positive terminal of a cell to negative terminal, what? पॉजिटिव टर्मिनल माने ये पॉजिटिव टर्मिनल है, एंड इधर से अगर हम मूव किए नेगेटिव टर्मिनल में, तो माने क्या? लोअर पोटेंशियल. सो वोल्टेज ड्रॉप क्या होगा? ऑटोमेटिकली नेगेटिव. सो नेगेटिव माने जो ईएमएफ होगा उसको हम माइनस ई करके लिखेंगे. क्लियर? सो नेगेटिव जो माने जो ईएमएफ आएगा उसको हम माइनस ई करके लिखेंगे. नेक्स्ट, अगर इसका उल्टा हुआ तो नेगेटिव टर्मिनल से अगर हम मूव किए पॉजिटिव में, देन व्हाट विल हैपन? देन पॉजिटिव होगा माने प्लस ई. ठीक है, सो प्लस. सो दीज 3 रूल्स आई होप यू विल कीप इन माइंड. ठीक है, चलो लेट्स टेक एन एग्जांपल ऑफ ए सर्किट. ठीक है, सो दैट वी कैन डू इट. नाउ सी, दिस इज द सर्किट. लेट्स से this battery is having an EMF E, this is also having an EMF E, all are having same EMF E and E. Now let say it is given कि this is I. ठीक, no, not this. Let's not take this as I. So we will consider this as not I. Okay, so let us take this as I. What is our I? This is I. Okay, this is our I. Now what will be this? This will be my I1. This will be my I2. Now which law? Again, see, first law is coming. So I equal to, the very first thing we will do, I equal to I1 plus I2. ये क्या है? ये Kirchoff's first law. ठीक है, फर्स्ट लॉ. ठीक है, Kirchoff's first law or the junction law. ठीक है, this is equation number 1. ठीक है, now see, let us name the loop. See, we have two loop. Loop माने this closed circuits a loop. Either we have, this is one loop, this is the second loop, and the entire thing is the third loop. Okay, so let us name the loop A, B, C, D, E and F. Okay, A, B, C, D and F. Now be very careful. So let us consider, see, current is flowing in what direction? This direction. So we will go like this. Okay, we will go like this. So considering loop 1, considering loop 1. So loop 1 में क्या होगा? देखो ये करंट इधर गया. Now इधर क्या, हम अभी हम इस लूप का बात नहीं करेंगे. ठीक है, we won't discuss about this loop. So what is happening? This current is flowing like this. Now see, we are moving in the direction of current. R is there. So what will be the potential drop? Minus IR1. Clear? Now see, we came to this loop. Okay, we came to this loop, nothing. So now here also see, this is I. So what will happen? This I2 will go there. This will come here. I2 will come here. And I1 will also come here. And together they will, I1 will again come here. And together again they will join up and form what? Form our I. So here we are moving from in the direction, we are moving in the direction of current I. So what will happen? Again minus IR. Done. Now see, this F, nothing is there, no problem. Now comes the battery or the cell. Positive terminal, lamba wala, positive terminal, chota wala, negative terminal. So positive to negative we are moving, na, mane higher to lower potential. So what we will write? Minus E. Minus E. Done. Very good. Now see, again A, nothing is there. Now from minus to plus. So what we will write? Plus E. And again we came to the junction B. So it is total loop complete. So this is equal to 0. ठीक. Now see, what can we write? We can write like this, ki minus I1, this will be I1. I1 R1 minus IR equal to 0. Okay. So I1 R1 equal to minus IR. ठीक. So what will be my I? I will be equal to minus I1 R1 by R. This is my first equation. This is my first equation. Now if you consider this loop, this second loop, okay? So what will happen? Loop number 2. Loop number 2. So let's move. चलो इधर से जाते हैं in the direction of I2. चलो. So minus से this is plus. Positive लंबा terminal है तो plus. So what it will be? It will be E. Okay. Here negative to positive, so plus E. This is also plus E. Then here I2 is flowing, so I2 this in the direction, so minus I2R. And here it is what? Against. Now see, we will move when we will enter this region. Here we are going against this I, na? So it will be what? It will be plus I1R. And this will be equal to 0. So what we are getting? 2E minus I2R plus I1R equal to 0. This is our second equation. Okay? Now see, you can consider the entire loop. Okay? Try this at your home. Okay? See whether you can get it or not. And using these, now see, we are getting total 3 equations, right? So using these 3 equations, we will solve solve the question which will be given to us. Okay? I hope this example is clear. Now, after, important thing, see, in examination, don't get afraid if you are getting the answer as negative minus 2 ampere. Okay? You may get minus 2 ampere. Why? Because first check whether your calculations are right or not. Okay? If you see that okay, calculations are good, you have done, you had put the put things in order. Okay? So if ऑल दिस इज करेक्ट, देन डोंट वरी, नेगेटिव आ सकता है. क्यों नेगेटिव होगा? बिकॉज नेगेटिव माने तुम जो डायरेक्शन में ले रहे हो करंट को, करंट इज फ्लोइंग इन द ऑपोजिट डायरेक्शन. यू आर टेकिंग इन द, सपोज इधर हम लोगों ने क्या लिया, राइट साइड में जा रहा है ना करंट, बट माइनस माने वी आर टेकिंग इट इन द नेगेटिव डायरेक्शन, माने इट विल इन द दिस साइड, करंट विल गो इन द दिस साइड. ठीक है. सो नेगेटिव इन फिजिक्स माने, माइनस इन फिजिक्स इट इज यूज्ड in certain places to indicate either the direction change or to indicate whether it's decreasing or increasing. Now decreasing increasing तो इधर कोई बात नहीं है ना, तो इधर क्या आएगा, इधर वही आएगा कि पॉजिटिव में, जो डायरेक्शन तुमने सिलेक्ट किया है वही डायरेक्शन पे अगर होगा तो पॉजिटिव में ही आएगा आंसर. अगर नेगेटिव में आ रहा है तो मीन्स योर डायरेक्शन इज रॉन्ग, डायरेक्शन ऑपोजिट होगा. ठीक है. सो यू विल राइट इट इन दैट सेंस. ठीक है. चलो, नाउ लेट्स मूव टू अ क्वेश्चन विच केम इन जेई 2005. ठीक है. Now, see, it says in this circuit the galvanometer shows zero deflection. Zero deflection, okay? If the battery A and B have negligible internal resistance, माने internal resistance R is zero. ठीक है. They are asking us to take R as zero. So, find the value of resistor R. ठीक है. Find the value of resistor R. Okay. चलो. So, now see, इन जीरो गैल्वेनोमीटर का काम क्या होता है, टू डिटेक्ट द प्रेजेंस ऑफ करंट. ओके. सो अगर गैल्वेनोमीटर कोई डिफ्लेक्शन ही नहीं शो हो रहा है तो इसका मीनिंग क्या है, इस ब्रांच में आई का वैल्यू क्या होगा, आई इज जीरो. आई का वैल्यू क्या है, जीरो है. ठीक है. सो वॉट एवर करंट इज फ्लोइंग, करंट इज गोइंग दिस वे, दिस गोइंग लाइक दिस एंड देन थ्रू दिस रेजिस्टर आर एंड देन अगेन गोइंग ओवर हियर. क्लियर. माने ये जो ब्रांच है, ये ब्रांच से कोई करंट नहीं जा रहा है. ठीक है. सो नाउ वी विल अप्लाई व्हाट, वी विल अप्लाई कर्शॉफ्स लॉ. ठीक है. चलो, लेट्स अप्लाई. सो लेट्स नेम द लूप ए बी, सॉरी लेट्स टेक दिस एज बी. चलो, सो ए बी सी डी ई एंड एफ. ओके. नाउ different methods are there, but I am taking this to solve by taking this example to solve so that I can solve it using Kirchoff's law. ठीक है. चलो, लेते एक लूप लेते, लूप का नाम देते हैं ए बी ई एफ, फर्स्ट लूप. चलो बोलो कैसे होगा. आई कहां मूव हो रहा है, आई इधर से मूव हो रहा है. चलो इधर से स्टार्ट करते, ए से स्टार्ट करते. देखो माइनस टू प्लस में जा रहा है बैटरी का, तो ये क्या आएगा, 12 वोल्ट हो गया. देन आई के डायरेक्शन में मूव करो. सो आई एनकाउंटर किया 500 को, आई के डायरेक्शन माने नेगेटिव 500 आई, वाई 500, आर का वैल्यू क्या है, 500 है ना, तो 500 आई. नाउ कमिंग टू हियर, दिस वी डोंट नो, दिस रीजन डोंट नो, सो माइनस आई आर. डन. नाउ हियर ऑल्सो नथिंग, सो दिस इज इक्वल टू व्हाट, दिस इज इक्वल टू जीरो. सो ठीक से लिखते हैं इसको. सो 12 इक्वल टू 500 प्लस आर आई. डन. सो आई का वैल्यू क्या आ गया इधर से, 12 by 500 plus r. Done. This is our equation number 1. Now see, let's come to this equation, this thing. So क्या होगा इधर b c, now loop ले लो, b c d e. चलो, सो बी सी डी लेते. बी सी में कोई करंट नहीं है, सी डी में कोई करंट नहीं है, बट वोल्टेज ड्रॉप तो होगा ना, बिकॉज दिस इज देयर. सो चलो, माइनस टू पॉजिटिव में जा रहा है तो 2 वोल्ट. ठीक है. इधर कोई करंट, डी में नो करंट, सो नथिंग. ई बी में करंट है क्या, है, ऑफकोर्स है, बिकॉज दिस आई इज देयर ना. सो वी आर मूविंग इन द डायरेक्शन ऑफ द करंट. सो व्हाट इट विल बी, सो माइनस आई आर एंड इट विल बी इक्वल टू व्हाट, इट विल इक्वल टू 0. चलो, सो व्हाट वी विल राइट, आई आर का वैल्यू क्या आ गया, 2 वोल्ट आ गया. ठीक है. नाउ आई का वैल्यू क्या था, 12 था ना. सो 12 बाई, सो दिस इज इक्वेशन 1. नाउ इफ यू सब्सटीट्यूट, सॉरी दिस इज इक्वेशन 2. सो इफ यू सब्सटीट्यूट द वैल्यू ऑफ आई फ्रॉम इक्वेशन 1, व्हाट आई विल गेट, सो 12 अपॉन 500 प्लस आर इंटू आर इक्वल टू 2. So let's simplify. So 12R equal to 1000 plus 2R. So क्या आया, 10R equal to 1000. So R का वैल्यू क्या आ गया, R का वैल्यू आ गया 100 ohm. So answer is A. ठीक है. I hope after watching this video you will have no problem to solve any numericals regarding this relating to this Kirchoff's law. Okay, students, please be very careful. This sum is very important. Each and every year, be it in JE, be it in NEET, be it in any CBSE 12 examination or any other thing, this type of sums will be there and they will give you good marks. Okay, so you will get an edge from other students. Okay, if you solve this kind of sum. Okay, chalo, I hope you like the video. Let's meet in some other video. Okay, bye.